Ooh, who discovered math? Good question. The answer is, all right. Let's look at this. Today we're looking at cosine functions. Think about your notes yesterday. What's a cosine function? It's the x-coordinate. What's cosine curve? The graph of cosine. What's cosine theta? It's the x value on our unit circle. This is going to be almost an exact repeat of yesterday, just shifted over pi over 2, right? So we get another opportunity to learn it. But I will go a little bit quicker. So we're going to use the 5-point method again. But we aren't going to start at a 0. What do we start with cosine? On the unit circle, what is cosine of 0? 1. So what is that point? That is a max. So with cosine, we start with a max. So it's going to be max, intercept, min, intercept, max. Does that make sense? It's just shifted over. Pi over 6 is root 3 over 2. Where am I getting these values from? Unit circle, right? Now what is this thing right here? That is a intercept. And then remember, we're going to hit 0. Then we're going to keep going down to -1/2. Negative root 3 over 2. At pi, we are at -1, which is a min. So we went down, and then we're going to go back up, right? It's going to look like this, just at reversed. Reverse, reverse. Everybody. Nope, that's going to get me monetized, guys. We're going to hit an intercept. And then we're going to end at a max. Right? Again, exactly the same as what we did yesterday, just shifted over pi over 2. If I were to pull this and push it over here, they're the exact same graph. That's why it's called cosine, right? It's sine and cosine, not sine and a whole different name. You know what I mean? Ooh, that's it. Never mind. So where is this beast increasing? Where is it going up? From here to here, I went down, right? And then I continue to go down. But then what happens from here to here? It goes up. From -1 to 1, I'm going up. So here I'm increasing. What's my x values? Because I'm talking about the where. It's pi to 2 pi. Do y'all see that? And if you were to graph this curve, it makes sense because it looks like that. Or if you look at the unit circle, from here to here, my x is going left. And then from here to here, it's going right. Do you know what I mean? So from 0 to pi, my x is getting negative. And then from pi to 2 pi. I'm just showing you multiple ways. You don't have to know it either which way. All right, I'm going to do the same thing I did yesterday. So for C, where would I be decreasing? Well, the other part, from 0 to pi. So, what are my maxes and what are my mins for D? So my max I have 2 points on this one, right? I have 0, 1 and 2 pi 1. On this interval, right? There's infinite maxes, right? Could I have put 0 plus 2 pi n, comma 1, because it'll repeat every 2 pi. Same with my mins, which only occur once on this interval, but that's pi -1. Now again, I could have done pi plus 2 pi n, comma -1, because it's going to repeat forever. All right. Oh my gosh, there's only 2 pages to go. Let's do it. Anything too scary on this one? All right, let's get it. Let's do this. Look at this. So again, that's what cosine's going to look like, right? We start max, intercept, min, intercept, max, right? I'm just going to write, so we're going to go max, intercept, min, intercept, max. So now at this point, you should be able to tell pretty quickly when you look at a graph if it's cosine or sine, right? Do you start at 0, 0, or do you start at the amplitude? All right. All right. Look at, have you ever seen this before? It's the exact same thing. What's my domain of all my, of my sine and cosine? All reals, also called negative infinity to infinity. Remember, you could say this too, right? Same thing. What's my amplitude? How do I know how far up and down to go? A. Remember, the negative doesn't do anything to the amplitude. It just flips it. What's my range going to be? It's going to be whatever A is, right? It's going to go from negative A to A, right? Will be my range. If it's not shifted, we will shift these eventually. We'll shift them. And what's my period? 2 pi over B. And my key points are going to be my max, intercept, min, intercept, max. Probably. There's no one watching. Well, I'm gonna let you guys in a secret. There's always people watching you when you're a teacher.
Yeah, but like, people you don't know.
No, we'll be best friends. All right. That's the creepiest thing that's happened today. All right, so here we go. Let's do an example. Oop. Oh, we're going to do this problem just like we did the problems yesterday. Okay? So if you didn't get yesterday, you get another opportunity. If you did get yesterday, review. So there's my problem. I'm going to do this by the rule way, and then there's a way I could do it without the rule way as well. So what's my xy going to become on this one? Is anything happening to my x? No. So it's going to stay the same. Is anything happening to my y? Yeah, I'm going to multiply by 1.5. Okay. These key points we came up with on that first page, right? These are my 5. My max, intercept, min, intercept, max, right? So what's 0, 1 going to become? It's going to be 0, 1.5. Do you guys see how I got the 1.5? Okay. What'd I do? Oh, eep. Sorry, whoever's watching. My homies. All right. So what's going to happen to my pi over 2 for this point? Is anything going to happen to it? Nope. What's 0 times 1.5? 0. So that stays an intercept, which makes sense. My intercepts, if I'm not moving it up or down, are just going to stay at intercepts. Doing nothing to my x coordinate, Negative 1 times 1.5 is negative 1.5. Now, I know I said this yesterday, and I love repeating myself. From here, could I graph the rest of it without like writing the points? Because it's periodic, so what do I know has to happen? I'm going to have to go back up, right? Like I know that that's how it's going to have to be, right? Because it's going to be a wave. Let's see if I was right. My x stays the same. 0 times 1.5 is 0. Beep. My 2 pi stays the same. 1 times 1.5 is 1.5. Oop, you see. Again, if you see a lot of these and they want you to graph this, do you have to make this chart? Could you just take your normal cosine like this and go from 1.5 to negative 1.5? Of course you can. But I'm showing you why. Because once we get to the ones with shifts, it's going to be important to know this process. Does that make sense? It's going to make life a lot easier to know this process. All right. Okay, let's go. Are y'all at least a little bit impressed with yourself that like we're doing like this stuff? Like we're doing trig? Or no? No. They want us to describe it? No. I want to give myself a little bit more room. All right, let's use our 5 points and graph this beast. Uh-oh. What's that negative going to do? It's going to flip it. If it flips it, I know my graph's going to look like that, right? Instead of starting at max, I should start at min. But again, even if I don't know that, could I do this problem using the 5 points and it'll automatically do it for me, right? For this one, what's going to happen to my x? So we have a half in there, but remember, anything that happens to x is flipped. So instead of a half, it's going to be 2x. And what's going to happen to my y? It's going to be negative 2. So see, if I just do it this way, it's going to work no matter what. What's 0 times 2? 0. What's 1 times negative 2? Negative 2. Technically, if I know my period right now, could I just graph this without even doing the points though? My period would be what? 2 pi divided by a half, which is 4 pi. So when I know that this one's going to be over there, like if I'm not using the 5 points, I'm going to show you 5 points. And then could I cut that distance in half to find my upper, my max? Does that make sense? But now, that was only a little bit quicker. This is really quick too, right? What's pi over 2 times 2? It's 2 pi over 2. 0. But what happens to my 2's? Cancel. So I have pi 0. So this is going to be 2 times pi is 2 pi. Negative 1 times negative 2 is positive 2. Is that where I would have put it if I would have done the half thing? Yeah. Because I used to teach this where you cut it in half, and then you cut in half again to get it. It's not a great way to do it, though. It gets tricky when we have shifts and other stuff going on. So this one would be 2 times 3 pi over 2, 0. What's going to happen to my 2's? Cancel. So I have 3 pi 0. And 2 times 2 is 4. And 1 times negative 2 is negative 2. I did it right. How you guys getting at your curves?
Pretty good.
Okay, okay, okay. That's the sledding we're going to be doing on Thursday after school.
We don't have school. We're not gonna do this.
We're supposed to get 3 to 5 inches. To go sledding?
5-day weekend?
No, absolutely not. What, is my phone died?
It's like dark. It's really dark.
Oh, whatever. I only have one more, right?
3.
Oh, wait, what? What was my transformation? It was a flip vertically. Whatever, it dies, it dies. Flip vertically, vertical stretch of 2. And then what'd the half do to our horizontal? Yeah, that was a stretch, right? Because remember, it's opposite. So we flipped it, we stretched it, and we stretched it. Like a pizza dough. We flipped it, and we stretched it, and we stretched it. I should have been a comedian. Would you guys come see my show if I quit? And no? You,
As long as it's out here on your monetized YouTube.
my first one will be at graduation.
That's fine.
I'll be like, waka waka. What's the deal with... All right, what's my rule going to be on this one? Is anything happening to my x? Nope. Yeah, I'm going to do 3 times y minus 2. So this one does have a shift. So it's going to be a lot easier to use the 5-point method. Kind of. Because think about this. If I'm shifting it down to, where's my midline going to be? Right? So if I treat that like my 0, it's going to be the same graph, right? So I shifted my midline down. I got to give you guys credit on the quiz. Great job on the graph.
Thank you.
That's it, though. All right. So 0, 1's going to go to 0. What's